So what we're going to be doing today, I'm calling this 5.1 and 5.2 because your textbook really drags things out. And this is, honestly, this lesson is quite simple because the mathematics behind it is something you already know. It's from Unit 1. It has to do with transformations and stretches. What makes it different is we're going to be working with trigonometric functions, the graphs of trigonometric functions. And we're going to introduce some terminology that's different than terminology we used in the previous teaching of transformations. So what we're looking at today is sketching y equals sine x, y equals cos x, and then any variations of them that do not include translations. There's no h and k. And by the way, tomorrow, there's no h and k because we're going to call hc and kd. That's just what happens, okay? So we're talking here about using your knowledge of what the parameter a does to a graph, and we're going to apply that knowledge to the graphs of y equals sine x and y equals cos x, and we're going to do the same thing for b. But again, there's a change in terminology. To begin with, you need to be as intimately familiar with this graph as you are with something like y equals x squared. Okay? This is what we call a sinusoidal graph. It happens to be y equals sine of x, or f of x equals sine of x. And it repeats. It continues in this pattern over and over and over again. So there happens to be an x-intercept at pi, and there happens to be an x-intercept at 2 pi, and there will be an x-intercept at 3 pi. And the reason for this, I don't want to dwell on this, but the basic reason has to do with the unit circle. And sine of x on the unit circle is the y coordinate. So when the rotation angle is 0, the y coordinate is 0. So when theta or x is 0, the y coordinate on the unit circle is 0, which means sine of 0 is 0. When you get to pi over 2 on the unit circle, and the rotations on the unit circle are what x is on this graph. When you get to pi over 2, the y coordinate on the unit circle is 1, and that's why the sine of pi over 2 is 1. And then the y coordinate becomes 0 at pi, it becomes negative 1 at 3 pi over 2, and then it returns back to 0, and it repeats. It continues in that fashion. Before we get to the writing part of this, I want you to notice that all of these graphs have in an upper boundary and a lower boundary to them. They always bounce up and down between a maximum and a minimum, which is why earlier when I had sine of x equals negative 5/3, there's no solution because negative 5/3 is below this bottom line. The graph doesn't exist there. And I also want you to notice that all of these graphs have a weird kind of symmetry halfway in between the maximum and the minimum. It's not a reflective symmetry, but it goes just as high above that middle line as it does below that middle line. So what do we know about this graph? Well, what's the domain and range? The domain is x is any real number. The range is negative 1 is less than or equal to y, which is less than or equal to positive 1. And there would be nothing wrong with you writing it as negative 1 is less than or equal to sine of x, which is less than or equal to positive 1. This is just a fancy way of saying the maximum value of sine of x is 1 and the minimum value is negative 1. There's a maximum and a minimum. What are the intercepts? Well, if you look at the graph, the x-intercepts are multiples of pi, which really makes sense because when you think of the unit circle, sine of theta, which is sine of x here, is 0 at these two locations that I'm indicating, which are multiples of pi. You, of course, have to say n is an element of the integer number set. The maximum value of the function is positive 1. The minimum value of the function is negative 1. Before we go on to the rest of this little warm-up, I want you to think of this on this graph as what I'm going to refer to as the start point. It won't always be at the origin, but as we get more and more comfortable with graphing these things, you think of that as a start point. And I want you to try to get it in your head that the start point of a sine function is in the middle vertically and it goes up. Okay? Sine of x starts in the middle vertically and goes up. And then it goes up, down, down, and then up, to get to a point where that whole piece that I've just put those hashed lines on is going to repeat. If I just copied all of those dotted green lines or whatever they are and just pasted it over, I would get the next cycle. Okay? All right, here's where we have some new terminology. And it's really unfortunate, but we use the letter K to mean something in trigonometry that it does not mean in transformations, which is why we don't use K later on. K is called the period of a trigonometric function. And the period is how far it is horizontally. What is the domain over which it starts to repeat? So when we take a look at this graph, the period is going to be from here to here. That's the period, because after that it repeats. So this is K. I would like everybody to note that this happens to be K. And this happens to be K. And no matter where you label the period covers 4 sections of the curve. When we take a look at this one highlighted in yellow, the graph goes up, down, down, and up, 4 sections. When you take a look at this one highlighted in blue, the graph goes up, up, down, and down, 4 sections. This one over here, green, I guess, up, down, down, up. A period has to cover 4 pieces to get that curve. So what is the period? 2 pi. The distance from the start point to where it starts to repeat is 2 pi. And if we had this graph in degrees, we would write 360 degrees. The amplitude of a periodic function is the vertical distance from the middle to the top or the middle to the bottom. And that's why these dotted lines are kind of important. What I'm telling you is this is the amplitude. You can even label it on your graph if you like. It's half of the range, I guess, is maybe the way to look at it. So the amplitude of y equals sine of x and the amplitude of y equals sine of x is 1. Because that's where it maxes out on the unit circle before it starts going back down to 0. So the amplitude is 1. And we use capital A for the amplitude, not lowercase a. Here's the graph of y equals cos of x. So if you just bear with me for a second, this is the graph of sine of x. It starts at the origin on its way up. The graph of cos of x is identical, but it has been translated pi over 2 radians, if you like, to the left. But it's the same idea. And the reason why there's that pi over 2 shift is because cos of x is the x-coordinate. And on the unit circle, when the x-coordinate is 1, the y-coordinate is 0. And on the unit circle, when the x-coordinate is 0, the y-coordinate is 1, and that happens at pi over 2. So I would just like you to note that the start point is at the top. And rather than starting in the middle going up, it starts at the top going down. if you want, it's not necessary here, but certainly later on it will be, later on today and especially tomorrow, you can put in these, I call them guidelines, because when you're sketching these things, they're kind of borders. Before I get away from here, you can note that there's an x-intercept at pi over 2, 3 pi over 2. The x-intercepts occur every pi radians. Okay? So, what are the domain and range? Well, they're the same as the domain and range of sine of x. Domain is any real number. This graph extends indefinitely in both directions, left and right. And the range is -1 is less than or equal to y, which is less than or equal to +1. X-intercepts are pi over 2 plus multiples of pi. Maximum value is 1. Minimum value is -1. Again, this warm-up is just familiarizing ourselves with what these two graphs look like. They repeat every 2 pi, and we can even put that in for the period. If you go back here and you look, how far is it horizontally for you to go through 1, 2, 3, 4 pieces to get the 4 ups and downs, 2 ups and 2 downs, down, down, up, up? Well, it's still 2 pi. If you want to work in degrees, it's 360 degrees. The idea here is that you understand the amplitude is 1, distance from the middle to the top, that sine and cosine have the following properties. They repeat every 2 pi, they have an amplitude of 1. The minimum is -1, the maximum is +1. Those basic ideas. The difference between them is that sine starts in the middle going up, cosine starts at the top going down. So, what are the period and amplitude of this function? Well, I want you to notice that the y-coordinate of this point up top is 7 and the y-coordinate of this point below is -7, which tells you that this graph goes just as far above the x-axis as it does below. And that's going to change tomorrow, because we could shift this thing up and throw all of our rules out the window. So I think it's pretty obvious the amplitude is 7. Yes? Now, what is the period? Well, when we take a look at this x-coordinate being 12 and this x-coordinate being 18, horizontally it's 6 units. This isn't measured in terms of pi. These are radians, though, because I don't see a degree symbol. It's 6 radians from that minimum to that maximum, but that's only half the period. Right? This distance horizontally, or this curve, if you like, this up, up, this up, up, is only half of the period. So if it's 6 from the minimum to the next maximum, the period must be 12. Pretty basic question. We're going to come back to that a little later. So if I can get you to turn the page. Use your knowledge of transformations to sketch the following graphs and complete the information below. What we want to do here is come to conclusions that will allow us to avoid graphing things and just write answers. So we know that cos of x, and you can decide what you want to write or not write, starts at 1, and it arrives back at 1 after 2 pi. And if it's going to go down, down, up, up, that means it's going to reach its minimum halfway, and it will intersect the x-axis in these places. So do you agree horizontally I've chunked things into 4 pieces? And I'm talking about cos x. I'm not talking about the graph here. This is what cos x, thank you for the funny look. No offense. I knew I did something wrong when I looked over my shoulder and everybody was going, something's wrong here. Okay, would you agree I've chunked things into 4 pieces horizontally and it goes up to 1 and down to -1? This is what cos x looks like. Cos x goes down, down, up, up. You'll get better at drawing these after a while. So what's 2 cos x going to look like? Well, everything is stretched vertically by a factor of 2, which means the maximum is going to be here, the minimum is going to be here, the start point will be at the top, the x-intercepts do not change because stretching things vertically don't affect things. The minimum will be -2, it will be twice as great. So this is what 2 cos of x looks like. And if you want to redraw that thing to the left of the y-axis, that's fine. As I said, we're looking at this green graph so we can answer the questions at the bottom of the page. What is the domain? I hope everybody is clear. There's nothing you can do to that brown graph to change the domain. It goes on in both directions no matter what. What is the range? Well, now it's -2 is less than or equal to y, which is less than or equal to 2. What is the amplitude? 2. And I hope you can come to this conclusion quite quickly. That will always be the amplitude. If I stretch that original graph, whether it's cosine of x or sine of x, by a factor of a, whether it's positive or negative, doesn't matter, whatever the absolute value of that a is, that's the stretch factor, which is going to give us the new amplitude. What is the period? 2 pi. Are you with me on that? Okay. This would be 2/3, correct? So what's going to happen is, instead of going to +1 and -1, it will go up to +2/3 and down to -2/3, which tells us, of course, the amplitude is 2/3. Since sine would start here, going up, and a is negative, this graph would start there going down. But it's going to go down, and then up, and then up, and then down, and return to its location after 2 pi, which means the period is 2 pi. So it's going to end up looking like this. It will go down, up, and down, continuing. I'm not putting the arrows because we're just learning about what's going on here. I hope that everybody could write in what the domain and range are. The domain is any real number, continues in both directions. The range is -2/3 is less than or equal to y, which is less than or equal to 2/3. Maybe you can come to this conclusion, or you already have. That the negative of the amplitude is the minimum value and the positive of the amplitude is the maximum. Are we okay with that? Okay, sine of 2x. So to begin with, we don't write it that way. We write that. For some reason, the convention, the system that we've set up says you don't need brackets around that argument. It's implied. If you see sine of 2x, it doesn't mean sine of 2 and then multiply by x. It means 2 times x, take the sine. So there is no vertical stretch here, which means these are the kind of guidelines for whatever we sketch. And There's no reflection here because A is 1, so this graph will start here and it will go up. That's the start point and it will go up. The difference is this, and this is going to require a little bit of explanation, but I want you to hang on to it and think carefully here, because once you get it, we don't have to rethink it every time. There is a horizontal stretch factor by a half from unit 1. I hope you're all in agreement there, because B is 2. What that is going to do is take the period and make it half as great. Okay? And if you think about what I've just said, that means the period will be 2 pi divided by 2. It will be 2 pi divided by 2 because B is 2. And what I'm telling you is the period's always going to be 2 pi over B. Well, if there's a negative, we have to deal with that, but the period's 2 pi over B. We do not want to think here in terms of stretches. It gets too complicated. Just like we have said, oh, the amplitude is that. I am now telling you the period is that. And if B is a half, that means things get stretched horizontally by a factor of 2. When you take a number and divide by a half, you end up doubling that number. Well, what that tells us is it's going to return to kind of a start point, if you like, after one cycle over pi radians. Because, of course, you wouldn't write 2 pi over pi. You would simply write pi. So this is going to go up, down, down, up. We need to split it into 4 equal chunks horizontally. Not that it really matters. Well, like the next lesson and things we do in the next unit, you have to get better and better at practicing graphing these. All that is important here is you are able to look at that function at the top of the screen and say what the amplitude, period, domain, and range are. So the domain is x is any real number. The range is that because the amplitude is 1. Are we still okay? All right. So let's try this without graphing it, and then I'll graph it on the graphing calculator for us. Okay? It's cos of 1/2 x. It's y equals cos of 1/2 x. Well, I'm going to talk about the period here. Why is the period 4 pi? From a stretchy standpoint, since b is 1/2, there is a horizontal stretch by a factor of 2. If I take the regular run-of-the-mill period of cosine, which is 2 pi, and I double it, I get 4 pi. Or that's the period. If I multiply the top and the bottom of this by 2 to get rid of that pesky 2 in the denominator of the denominator, the bottom will become 1 and the top will become 4 pi. The domain, of course, is x is any real number. So if we go to our graphing calculator and you enter in for y cos of 0.5x, that's just how I would enter it. You need to remember something for the rest of this unit, and then that will change next unit. Always go zoom trig. Okay? So I want everybody right now to go zoom trig, which is zoom 7. And we will all be looking at the same graph. Correct? I hope. What's interesting here is if you hit mode, how many of you are in degree mode? How many of you are in radian mode? It doesn't matter what mode you're in. Your calculator said, this person wants a nice trigonometric graph. It looks at it in whatever mode you have and it scales it properly. If you're in degree mode, if you go to window, I don't know why they didn't program the calculators to go from negative 360 to 360. That would just make too much sense. It's negative 352.5 to 352.5. And if you're in radians, it's not quite 2 pi on both sides. So anyway, you can see that this graph is stretched out quite a bit. Actually, this is one period, isn't it? This whole thing is one period. Up, up, down, down. And if I'm going from negative 2 pi to 2 pi, that's 4 pi. You could also see that the amplitude is still 1. All right, so this is what we have learned. What we have learned is that when you put a and b together for either sine or cosine functions, the amplitude is the absolute value of a. The period, and I've already explained this, can always be found by taking 2 pi over the absolute value of b. This is a memory thing. It doesn't have to be. You could always go back and talk about stretches. But with what's coming up over the rest of this unit and the next unit, this will make your life easier if you can remember that. And of course, if you want a graph in degrees, you use 360 degrees instead of 2 pi. That's it. So this should take you almost as long to read as it should to write in the 4 answers. The amplitude is 3. And write capital A equals. Don't just write 3. Get used to that notation. The parameter A is 3. The parameter B is 2. That means the period is 2 pi over 2, or simply pi. It's 2 pi over B. And B is 2. Domain x is any real number. Negative 1, whoops. Negative 3 is less than or equal to y, which is less than or equal to 3. Are we okay with that? I hope. Eric, you're good? See, let me go back to this one. Imagine that this was a 3, and you want to do the stretchy thing. What that means is you're going to say, I'm going to take 2 pi and stretch it horizontally by 1/3, which I think requires a little bit more thought. Whereas just saying 2 pi over 3, because b is 3, is easier. Okay, I'm going to give everybody about 12 seconds or so to write out the domain, range, amplitude, and period for this particular function. Does it match yours? Put your hand up and down when you're done. Okay, that should be it, really. I'll give you a few more seconds, but this is the lesson. That's all there is to it, really. The domain is any real number for x. The range is negative 1/4 is less than or equal to y, which is less than or equal to 1/4. Speaking of 1/4, the amplitude is 1/4, and the period is, once again, 2 pi over b, which in this case is 2 pi over 1/2, which is 4 pi. How many of you still figure out the period, though, with a stretch? I'm just curious. I mean, if you do, that's fine. That's okay. There's nothing wrong with it. Are we okay with B? Determine an equation of a sine function with the following properties. Amplitude of 4, period of 90 degrees. Well, that means, well, I want to talk about this. I need to talk about this. Do you agree that this is the case? This is one of the things we've learned. I want you to note that if you rearrange this for the parameter b, it's the same kind of relationship. So in every example we've looked at, you knew b and you put it into the top equation to find the period. Here we know the period, you're going to put it into the bottom equation to find b. B will be 4. The absolute value of B will be the regular run-of-the-mill period divided by 90 degrees, which gives you 4. So, and clearly, well, I hope clearly, the absolute value of A happens to be 4 as well, because the amplitude is 4. That's an answer. That's an answer. We would want to put brackets around the negative 4x. 4 sine negative 4x would be an answer. It doesn't matter about the negatives. This one, y equals 0.5 sine. B is the regular period divided by the period. It's 1/3. Any questions with 4a or b? Okay. This is a cosine function of the form f of x or y equals a cos bx. We need to determine the equation from the graph. This is kind of like question 4 with a twist. Okay. It's kind of like question 4 because in question 4 you're told the amplitude and you're told the period. Here we have to figure out what the amplitude and the period are. Do you happen to have numbers on yours? You do? Is this dash 1 or 2? It's 1. Thank you. So this is 1, this is 2, this is 3, this is -1, -2, -3. I think it's quite clear that the amplitude is 3. Yes? Okay. I'm not saying little a is 3. I'm saying the amplitude is 3. And what is the period? Well, the period is 2 pi. Pardon me. What is b? B is 2 pi over the period of the graph. So what is the period? Well, you can pick any point you want. You just have to have 2 ups and 2 downs to complete a full period. If you want to start here, that would be up, up, down, down. Oh, it went pi horizontally. If you want to start here, which I don't know why you would, it goes up, down, down, up. I mean, then you're forced with figuring out what that distance is. Be smart about your choices. Work smarter, not harder. So the period is pi, which means b is 2. I'm just going to write over here, period equals pi. So the parameter b is 2. Now don't forget, this is not the parameter a, it's the amplitude. So why is it that this is not a correct equation for that graph? Joseph?
The graph is reflected.
Right. And how do you know it's reflected?
Because cosine graphs usually start at positive.
Right.
Positive.
Perfect. And that's exactly what I would have said. Cosine has a start point. You can say positive, but that's going to change tomorrow, okay? It's better to say top. Cosine normally starts at the top and goes down. This graph actually starts at the bottom and goes up. So in your words, you said there's also a reflection. A vertical reflection, which means that a, little a, is actually -3, and we're done. One final example. I feel in the back of my head, kind of one side of my brain is saying I've rushed this, and the other side is saying it's fine. Is it fine? Okay. Final example. What is the equation of this graph? Well, this happens to be the graph from example 1. If you were to go back to example 1, I gave you this graph, and I said, before we knew about little a and little b, I said, what's the amplitude and what's the period? And we said it goes from -7 to 7, So it's balanced vertically, which means that this is the amplitude of 7. And then I also said this minimum has an x-coordinate of 12. This maximum has an x-coordinate of 18, which means that it's 6 units horizontally for that section of the graph, but that's only 1/2 of the period. So the period is 12. The value of A is going to be -7 because it has to represent the amplitude being 7, but it also has to represent the fact that this graph starts at the bottom, and it's a cosine graph, right? Starts at the bottom going up instead of the top going down. And B, well, B will be 2 pi over 12, the period. 2 pi over B is the period. B is 2 pi over the period. So you get, and this is why I'm including this example, you get a parameter B which actually has pi in it, because the period was not measured in multiples of pi, it was just measured in pure numbers of radians. You get a pi as part of your equation. This is the equation.